Hi, I'm Romeo Gozens and my partner is Joe Harrison, and we did some research about comparison of number of decisions in overlapping and non-overlapping sudokus using set solvers. Overview. First, we're going to talk about the introduction of overlapping sudokus and our hypothesis. Then we discuss our methods and results, and then we talk about the discussion and conclusion. An overlap sudoku is two sudokus with an overlapping region, as you can see in the pictures below. We solve these overlapping sudokus using a set solver and we write it in the conjunctive normal form. Now let's talk about our hypothesis. Our hypothesis is as follows. The total number of decisions will be lower in one overlapping sudoku compared to solving two non-overlapping sudokus. Method. In our method, we want to tackle the following questions. What types of overlapping sudokus are there? How do we encode our problem into the CNF form? Which set solvers are there? And how do we generate overlapping sudokus? Well, the first question is, what types of overlapping sudokus are there and which we can use? We came up with the following. We have two sudokus, and on the first sudoku we lay the second sudoku on it, on the diagonal of the first one, as indicated as in the pictures, resulting in 8 overlapping sudokus. The second question. How do we encode our problem into CNF form? Well, we use Dimex for that. We did a little bit of research and came up with Dimex, and it's a format for CNF. Then the second question is which set solver we can use. We use CChef and Picosat. Mainly our code is written in Python, and therefore Picosat is very handy for decoding the sudoku. However, Picosat doesn't give us enough information, and therefore we use CChef for the statistics. The last question is, how do we generate data for the sudoku? Well, we found a site called Midoku, and they have overlapping sudokus with two sudokus. We download it, tweaked the JavaScript to generate all the desired shapes. Then we randomly assign numbers to cells, and then let the Midoku solver, written in JavaScript, solve the overlapping sudoku. Now we have overlapping filled-in sudokus. We then use the punched out method for punching out numbers and then to check if the solution is still the same as it was before. We do this till 10, 20, 30 till 90% of the information is punched out. Overview results. Okay. As a result of the punched out percentage, we get the following graphs. Here we see 4 graphs where each x-axis is the number of overlap and each y-axis is the number of decisions. The green line is the line of how many decisions the overlap sudoku needs to make. The blue line is how many decisions the separate sudoku has to make combined. We can see that if the number of overlap is high, the blue line is always lower than the green line for every punched out percentage from 10% till 40%. If we go to the next 4 punched out percentages, we see the same. However, if you look at the 50 and 60%, we can see that the shapes of the blue line and the green line are nearly the same. If we go even in higher punched out percentages, we have almost exactly the same shape, and in the high number of overlap regions, the blue line is still lower than the green line. Two things. When the punched out percentage is higher, the blue and green line needs to make more decisions. This makes sense because there is less information in Sudoku, so there are more clauses, and more clauses will result in more decisions. Another thing we noticed is that the number of overlaps is lower for the blue line than the green line in high number of overlaps. This makes sense. If a number is in an overlapping region, then this number has information for the first and the second Sudoku, and it only contains one information for the overlapping Sudoku. Therefore, the information for Sudoku 1 and 2 is more, and therefore less clauses needs to be solved. When we combine those two things, we can also reason about the high punched out percentage, why their shapes are almost the same. This is because there is so less information in the Sudoku, there are a lot of clauses that needs to be satisfiable. If a number is in the overlapping region, it won't even matter, because there are still a lot of clauses that needs to be set. We can also make another figure, and that is if we make a graph for each overlap, and then in the x-axis we have the punched out percentage, and on the y-axis we have the number of decisions. Here green is still the overlapping, and the blue line is still the separate Sudokus. Here we can see that if the overlap is low, the form is almost the same. If we look at higher overlaps, we see that the blue line is always lower than the green line. If we go one slide back, this is not always the case. This is because the overlap has more information for the separate Sudokus than the overlapping one. We can also see that if the punched out percentage for each overlap graph, the number of decisions becomes higher, as we discussed before. So, these were our results. We now go to the discussion and conclusions. So, we only experimented with 8 possible shapes. However, in theory, there are many different shapes. And it's better to investigate this. Another thing we could investigate is not using 2 Sudokus that overlap each other, but many more Sudokus. Our conclusion. Our conclusion is that our hypothesis is partially true. The number of decisions for separate Sudokus is lower, however, for high overlapping regions. As we discussed before, if the region is too small, the overlapping Sudoku can perform better in terms of decisions than the separate Sudokus. This was our presentation.